So I hope everybody has joined. Let us begin. Okay. So I was discussing in the previous lecture the graph of e power minus of x square. Okay? In this particular lecture, I'm going to take up a few more graphs, and we'll see how to go about them. Okay, how to go about them. I hope it is clear. Till now, it is clear or not? And don't worry, we'll come to the topic. Don't worry at all. Okay, so just keep patience a few more days. We have started. So because I don't know the level of each one of you, na? So each one of you are at placed at different places, and uh, each one of you are in the different stages of your life. A few of them are PhD students. A few of them are MSc ones. Is there anything to say? Somebody saying something? Okay. Am I audible now?
Yes, sir.
Yes, yes. Okay. So, I mean, everything is auto. You are getting everything now. I don't think there is a problem. Okay. Okay. Someone is sitting next. I don't. Okay. So, please muting your channel. I mean, muting your site so that I don't feel as if I'm on the railway station. So, okay. So now let us start with the things. Okay. I hope you don't mind with the humor. Okay. So just don't mind anything. So, what I was suggesting was, see, because we have started today only. So I actually wanted to start directly with quantum mechanics. Then I actually got slightly afraid because most often in my classes, what happens is, when I used to teach physics, like you can say supervisor, you can say one who was placed literally above me, he used to say, Sudeep, you have to go with the very basic. Otherwise, people would go away. So on the very first day, my class used to be of 40 people. The next day, the class used to be of 20 people. And the other day, I would finalize that these are the 5 people whom I'm going to teach the entire year. Okay. So I don't want to take this risk right now because you're already 8. And if it goes on decreasing this way, then it will remain that I'm again teaching myself on this whiteboard. So I started with basics. That is why uh, that is the case one. Okay. So let us begin. Okay, let us begin with the graph of e to power minus of modulus of x. And this is in particular a favorite example of that is usually asked even in your interviews also. Okay, so in interview usually it is asked on board that plot a graph of e to power minus x square, and they will also ask you plot a graph of e to power minus modulus of x, and then they'll say what is the difference between the two, and why do you think what has happened. So this is a kind of thing that you're usually asked. Okay, so just let us begin from there. I was just actually finding the problem, but somehow I'm not getting it. Fine. I know this particular problem was asked in exam. Okay, so just make the let's just make the graph of e to power minus mod x. First, always remember whenever you have to define modulus of x, this is something that you're going to see quite often in your different functions also, like different trial wave functions. If you want to do, especially a wave function, I'm writing here. So, for example, if the wave function is defined by is some constant times Dirac delta function. Okay. So sorry, if your potential is k times some Dirac delta function, you're bound to get this kind of wave function. Obviously, I'm not saying exactly this. Some constant would be there accompanied, but this is how your potential would. This is how your wave function would be. In quantum mechanics, where we are going to study Dirac delta potential, you'll find that this particular potential, for this particular potential or a particle which is subjected to this particular potential, will have a wave function of the form e to power minus mod x. Obviously, some constant would accompany it, but in general, the structure would be this. So this is an important structure that we should understand. Okay. Before understanding all these things, please first understand what is modulus of x. Usually in standard 12th or something, there is a misconceptualization in our area. I mean, till now, whatever I found, that if I ask someone what is modulus of x, the guy repeatedly says that it is plus minus mod x. I mean, this is not the right way of saying things. Okay, understand? If I'm writing mod x equals to a, then it implies x equals to plus minus a. It would be fine, absolutely. But otherwise, always remember what is uh, uh, what is modulus of x in general. Remember, modulus of x is nothing but it is equals to x if x is greater than, let's say, equal to 0 if you write here, and is equals to minus of x is if x is less than 0. What is the purpose of modulus of x? The purpose of modulus of x is to give you an idea of absolute value. And by absolute value, I mean it gives you an idea that whatever you're placing inside, after getting modulus of it, you are going to get in reciprocation only positive answer. So in case your argument inside is positive, then you're going to get a positive answer. If the argument inside is negative, then just place a negative in front of it. So overall, it becomes positive. So end result is this. So please, if you have this kind of doubt that whenever you have this mod x, you write it as plus minus 6, that is wrong. Although if someone asks you what is modulus of x equals to a, then your answer that x equal to plus minus a is absolutely correct, because the equation, this is an equation which suggests that what values mod should I take so that I get an a. So you will instantly say, okay, take a mod of a is equal to a, fine, or minus of a mod is again a. That is absolutely fine. So if I want to define this particular function, this will be e to the power x if x is greater than equal to 0, and it is minus x if x is less than 0. I have no such prejudices. I can even place this here also, because anyway, e to the power minus 0 is also 1, e to the power 0 is 1. I have just placed it on one end. Are you getting my point? I can equally place it here. So just don't think that I'm biased towards the positive side. No, that's not the case. Okay, I can as well put this equality here also. And this is one and the same thing, because e to the power 0 or e to the power minus 0 are going to be plus 1 only anyway. Okay, so now you have already seen, this was the context of GATE question that I've taken. The GATE question asked you in 2015, and why do I remember it so fondly? Because this came in my exam only. So e to the power minus x square happens to be a smooth function. You can see clearly it is where it has gone. Okay, so it is differentiable at each point. So it is even differentiable at x equal to 0. You see, x equals to 0. It is differentiable. If you don't think it is differentiable, you can also try finding the right and the left hand derivative, and you will find it as 0. Although from the graph itself, you can see that this is completely smooth. And what happens is, it is increasing at an increasing rate, then it is increasing at a decreasing rate, and then it is again decreasing at a decreasing rate. So this smoothness continues. Had this not been the case, then this particular point would have been a point of contention. So right now, this is a completely smooth graph. Okay. Now you see, what about e to the power minus of modulus of x? How do you make such graphs? So first, you should have an idea of the exponential. So I'm just making a graph of exponential. See, and remember, don't have this bias that only e to the power x is exponential. Even 2 to the power x is also an exponential function. So what I'm going to do, I'm going to make a graph of a to the power x. So this is how you make the graph of a to the power x, a greater than. Okay. And how would be the graph of a to the power x? If a lies between 0 and 1, this is how it is. So a to the power x, if a lies between 0 and 1. And this is the point 0, 1. Is that clear? So a to the power x is an increasing graph if a is greater than 1. A to the power x is a decreasing function if a lies between 0 and 1. And this is something that usually students do wrong. See why? Always keep this in mind that, let's say, I'm writing two things. Let's say I'm writing that 4 is greater than 3. Now, if I say that put this particular function, apply these particular function on both sides. So usually students do this way. Okay, fine. They say that, okay, yes, 16 is greater than 8. But always remember that this was an increasing function. An increasing function always preserves the order. It always preserves the order. However, if you are dealing with a decreasing function, then it would reverse the order, certainly. So let's say if I was dealing with 0.2 to the power x, now your argument will be valid. Now you see, if I'm doing this, is it wrong or right? This is wrong. Why this is wrong? Because now you are dealing with a function which is a decreasing function. So whenever you have this kind of thing, whenever you have, say, arguments, let's say there are two arguments, let's say x1 is greater than x2. And if you want to apply functions on both sides, please keep in mind whether the function is increasing or decreasing. If the function is increasing, preserve the order. If the function is decreasing, reverse the order. Otherwise, there would be a discrepancy. See here, it could be 1 by 16 is greater than 1 by 8, which cannot be the case. Why it is happening so? Because you know that 0.2 to power x is a decreasing function. See here. I hope it is clear for each one of you. I don't think there is a problem. If there is one, please let me know. And you can also unmute yourself and say, because right now only 9 people are there. So even if you unmute, only a slightly beat pattern would be created, nothing more than that. Okay, so is that fine or not fine? Please let me know.
Yes, sir.
Okay, good. So, let us move ahead. Okay, and all well with the language now. So I don't know, because see, there are students from South India as well. So I have to keep lingual uniformity. So that's why I'm just sticking with English. I hope everybody is following what I'm saying. Okay, so you see, now I have to plot the graph of e to the power x. So how would e to the power x be plotted? So I'll make it in a dotted sense. I'll make a graph of e to the power x. So this is how your graph would be of e to the power x. Okay, and how do you plot a graph of e to the power minus x? So what is e to the power minus x? Remember, e to the power minus x is writing 1 upon e to the whole power x. And what is 1 upon e? You know that it is around 0.36 or something. So basically it is in 0 and 1 only. So if I have to plot a graph of e to the power minus x, this is how it is. I hope it is clear. Okay, now just come back to the problem. What was the problem? Problem was plotting the graph of e to the power minus mod x. So what it was suggested that only for x greater than equal to 0, just plot the graph of e to the power x, and for all x less than 0, plot a graph of e to the power minus x. So what it says that for all x greater than 0, just keep e to the power minus x. So I'm just keeping this. I'm forgetting about this. Forget about this. For all x greater than 0, just plot the graph of e to the power minus x. Certainly, this will be asymptote. So in long run, it is going to be asymptote. And for all x less than 0, just plot the graph of e to the power x. Okay. Now, there is a sharp edge here. This particular edge is sometimes referred to as cusp in mathematics sense. So there is a cusp at x equal to 0. Clearly, e to the power minus modulus of x is non-differentiable at x equal to 0. So wherever you find these sharp edges, you can do so. Otherwise, if you want to use the definition, you can also use the definition limit h tends to 0. Do it f of 0 plus h minus f of 0 divided by h on one side. This is the right hand derivative. Left hand derivative would be limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h. Do both of these things and see whether these are equal or not, whether the right hand derivative is equal to left hand derivative. And this is an exercise that you can do at home. But right now, I've just shown, so what is that word for the sharp point? Cusp, C-U-S-P, cusp. Okay, this is a technical point. So there are different points that are defined for non-differentiability. One is called as cusp, other are called as non-different double points. You don't have to go into all these things, but just remember, this is referred to in technical term as cusp, C-U-S-P, C-U-S-P, cusp. Just remember this word. So wherever this kind of variation, this kind of sharp edge you find, this is called as cusp. So you have a cusp at x equal to 0, and these are the points of non-differentiability. Otherwise, also you can see, if you just see the derivative here on the left hand side, if I want to make a slope, so slope would be this way. If I want to make the slope on x greater than 0, this would be the slope. So clearly here the slope is negative, here the slope is positive. Okay, so you just see the here. So just make a tangent here, just make a tangent here. You can clearly see the tangent on the left hand side is making an acute angle, and tangent on the right hand side is making an obtuse angle. So basically, for on the right hand side of x equal to 0, the derivative will be negative. On the left hand side of the x equal to 0, derivative will be positive. So clearly there is a distinction between the right hand and left hand derivatives that you can also verify with this standard 12th definition. I'm not going to do this. I think this is something that you are well aware of. So this is how. So clearly, if you want to mark a distinction between the two, see e की power minus modulus of x and e की power minus x square. This was asked in GATE 2015. So this was the premise of whatever I was teaching you right now. Are both continuous at x equal to 0. The continuity is not affected. See, continuity is not affected. See, whether you take limit h tends to 0 e की power minus modulus of x, you are going to get one only. And limit x tends to 0, if you want to take off e की power minus x square, whether the right hand limit or left hand limit, they're going to come one. But the derivatives are not the same. Are continuous at x equal to 0, but they are non-differentiable at x equal to 0. But e की power minus modulus of x is non-differentiable at x equal to 0. However, e की power minus x square is differentiable at x equal to 0. I hope it is clear.
Yes, sir.
Now just try to plot a graph of, I'm giving you a graph. Let's say another another things, a few of the things that you quite often find is hyperbolic functions. Let us plot sine hyperbolic and cos hyperbolic. Let us plot sine hyperbolic and cos hyperbolic. So let us find the graph of sine hyperbolic and cos hyperbolic. So how would you do? So let us first define what is sine hyperbolic and what is cos hyperbolic. So what is sine hyperbolic and what is cos hyperbolic? Okay, so let us plot that. Okay, so if I have to write what is sine hyperbolic x is simply e की power x minus e की power minus x divided by 2. And what is cos hyperbolic x? It is equals to e की power x plus e की power minus x divided by 2. Okay, so now let us make the graph of it. So first let us make the graph of sine hyperbolic x. How would you do that? Just give me a time. I think I can do something. Okay, so this is one. Now let us first think how would you make a graph of, so I am going to make a dotted graph. So e की power x, how would you do? This is how you make the graph of e की power x, right? So this is your graph of e की power x. What is the graph of e की power minus x? The graph of e की power minus x is this. And say, if there is a graph like this I'm drawing, this is your y equal to f of x. And if I multiply this with negative, so what will happen? It will get reflected this way. So for example, you have a graph of, let's say this is your graph. And if I'm multiplying it with negative, what will happen? So if I multiply with negative, so what will happen? Minus y. So for all those x will remain the same, but y would be on the negative side of it. So it will be symmetric, and you can make an image taking x-axis as your mirror. Okay, so this will be the graph of y is equal to minus of fx. So if this is your e की power x, this is your e की power minus x, what would be minus e की power minus x? This would be minus e की power minus x. Is that clear? Now we should make a graph. So what this graph says, it says that if you want to make a sine hyperbolic graph, you have to take sum of e की power x and e की power minus x and then divide by 2. So in any case, what will happen? If I sum these two, what is going to happen? You're going to have something in middle. So you're going to have something in middle. So, and also as x tends to minus side, that is x tends to minus infinity, what would dominate? Obviously, e की power minus x would dominate. E की power minus x would dominate. Is everybody following or not following? See, what will happen? For all x less than 0, if I'm trying to make this particular graph, what will dominate? Obviously, e की power minus x would dominate. See, so at very large minus infinity, only this will dominate. See, as x tends to minus infinity, if you see, your e power x would go to 0. But your e power minus x would not go to 0. Sorry, not this graph, these two graphs, sorry. This graph and this graph, sorry. This is your e power x, this is your minus e power minus x. So as x tends to minus infinity, which is the graph which is going to dominate? This is the graph. Is everybody understanding the point or not understanding? Please let me know what.
Yes, sir.
Okay, good enough. Chalo. So what will I do? What I'll do from here, I'll start. And then obviously this is going to create some impact, isn't it? But overall, this will remain as this way. What will happen at x equal to 0? At x equal to 0, you can expect a 0 because at x equal to 0, this is 1, this is 1. Now what will happen for all x greater than 0? You have to make a graph of this and median of it. So it is going, as x tends to infinity, it is going to approach e power x. And x tends to minus infinity, it is going to approach e power minus x. Not even this. Not even this. Just give me a minute. Okay, so this will be like this, straight. It will not deviate anyway. And then from here, it will start deviating. Is that clear? So now let us redraw this graph here. So if I have to make this graph, this is an understanding. Okay, now let us make a graph of sine hyperbolic. So this is e power x minus e power minus x divided by 2, right? Now I have got an understanding that how graph would behave. Now let us do it by derivatives. Okay, as x tends to infinity, where the graph will go? Obviously infinity. As x tends to minus infinity, how the graph would go? Clearly minus infinity. This is clear. As x tends to minus infinity, this would become 0, this would become infinity, negative is placed in front of it, so minus infinity. Now, at x equal to 0, you know that sine hyperbolic is 0. This is clear. Okay. Now you see the derivative. So derivative of sine hyperbolic x is cos hyperbolic, which is also, you can see the derivative d by dx of sine hyperbolic happens to be e power x plus e power minus x divided by 2. This is positive. So the function's first derivative is positive. And this is positive for all real r. So the function would be increasing throughout, which indeed you can see here as well. Function is completely increasing. Obviously, I could not make it nicely, so I'm just trying to show you again. But you should understand, we are just doing the summing behavior. So just we want to see the summing behavior of e power x and e power minus x. You could have done it in the exam in this manner only. But just for the sake that I taught you something, so I'm just doing it for you. So f dash x is greater than 0. And d by dx of sine hyperbolic x is e power x plus e power minus x divided by 2. Is that clear? Now you see, this is one thing. Now, if I want to take the double derivative, so double derivative would again be e power x minus e power minus x divided by 2. Find that when it is greater than 0. It would be greater than 0 whenever e power x is greater than e power minus x, or e power 2x is greater than 1, or x is greater than 0. So for all x greater than 0, your function would be increasing at an increasing rate. You can clearly see this was the case here. Increasing at an increasing rate. And this will be less than 0 only if e power x is less than e power minus x, or I can say e power 2x is less than 1, or you can say x is less than 0. So whenever x is less than 0, then your function would be increasing at a decreasing rate. So this is a mistake that we have done. Okay, in this graph, we have done this mistake. So this is decreasing at a decreasing rate, but obviously I could not make it in the right concave way of making it. So let us redo it. So actually I was trying to assess an idea from the summing behavior. Fine, let it be. Summing behavior. This is what I'm speaking. If things are not clear, summing behavior. And you should understand, you may understand what I want to make a sense of summing behavior. See, I want to sum the behavior of this and this. So this is what I was doing initially. Now I've done a calculus kind of approach that I have taught you. And this is very important. See, I have found students getting confused quite often in this. How would the graph behave? How would the graph not behave? I always say that just keep in mind only these few things, because see, there is a quotation which says, if you want to travel more, keep your baggage less. I mean, this applies in life also. If you want to travel more in life, keep your emotional baggages aside. Okay. So that is a different altogether philosophical connotations to this particular thing. But if you really think with respect to net exam, if you want to travel along in net examination, keep all very basic thing in your mind itself. Don't remember all those. Okay, I have to remember each and every graph. Now, if you are going to remember each and every graph, then in exam you're bound to get confused. You're already there. See, a few of the things you have to remember. Let's say, for example, whenever I used to write my examination, outside the examination center, I used to keep reiterating myself the formula of bond approximation, because you know that integral on any day you cannot derive it in exam. You have to remember it. So there are things which you have to remember. Now, in that particular remembering thing, if you're piling up a list that, okay, I have to remember the graph also, I have to remember the integrals also, I have to remember everything, then you're bound to get confused. So if you want to travel more, keep your baggages less. So whatever basics are there, do a good amount of practice for them so that they get instilled in your brain. Okay, even if you don't know the graph, I'll make it in a minute or two. But if you're going to remember each and every graph, this is how it is made, this is how it is made, this is how it is made, then your exam is gone. Okay, because then there are too many things to remember. Already there are too many things to remember. Let's say semiconductor physics. In any case, you have to remember it. Okay, you have to remember the formula. You cannot help it. Even if I derive it, even if I write all sort of good theories about it, at the end of the day, for examination per se, you have to remember those formulas. I mean, this is the requirement of the examinations. We cannot even complain. So now let us make the graph. So for all x less than 0, function was increasing, but at a decreasing rate. At x equal to 0, it was 0. And for all x greater than 0, it is increasing at an increasing rate. It is not even this. Please remember, this is just increasing at a decreasing rate and then increasing at an increasing. This is how your sine hyperbolic function would be drawn. You can clearly see this is an odd function, so it is symmetric about origin. Again, I hope everybody has got what I wanted to convey till now. Now let us try to make the graph of cos hyperbolic x. Tan hyperbolic I have already drawn, so I'm not drawing that graph. You can see those lectures, I have already recorded them up. So how to make the graph of cos hyperbolic? So again, for cos hyperbolic, the ingredients are nothing but e to the power x and e to the power minus x. So you just see the summing behavior of the both. Now here, there is no such discrepancy. This is e to the power minus x. This is e to the power x. So if you see the summing behavior, for all x tending to infinity, this side will dominate. Obviously not exactly from here, but understand, it will actually go a little up. It will go a little up. So basically it will be from here. And for all x tends to infinity, e to the power x. So I'm sorry, just give me a minute. So let me first make the graph of what I wanted to convey was not conveyed. So just give me a minute. I hope everybody is following now. Please say yes in the chat box if that's the case, and if it's not the case, please let me know what is troubling you. So this is e to the power minus x, and this is how you make the graph of e to the power x, isn't it? Okay. Now you see. Okay. Now you see. This is at x equal to 0. This is these two are meeting at the juncture at x equal to 0. At x equal to 0, both of them at 1. Now you see, if I want to make the summing behavior, see, as x tends to infinity, which of them do you see dominating? You can clearly see that x tends to infinity. This particular fellow is just going towards 0. It is not even contributing. What is the most thing that you think that would contribute this? At x equal to 0, it will be around 1. So basically, what will happen? Initially, it's fine. Initially, it will not trace exactly e to the power x, but at x tends to infinity is just going to trace what your e to the power x would be. And at x equals to minus infinity, it will trace exactly e to the power minus x. But otherwise, this is how. So you can expect this kind of, I will not say parabola, but a kind of graph which is symmetric about this. Now let us try to make without having this knowledge. If I want to make it using the derivative aspect. Okay, so let us make the graph of cos hyperbolic x without knowing all these things. Okay, first, let me know what will happen at x tends to infinity. At x tends to infinity, cos hyperbolic x would obviously go towards infinity. At x tends to minus infinity, cos hyperbolic x would go towards plus infinity. Clearly, you see. Minus infinity, this would dominate, this would be infinity, and this would be 0. How would your function behave at x equal to 0? It would be equals to 1. See, e to power 0 is 1, e to power minus 0 is 1, divided by 2, 1 plus 1, 2 divided by 2 is 1. Okay, now, there is another problem with me. I speak so fast that even if you are going to put your channel on 2x, it will be actually 4x. So, so already if I'm, you can only afford till 1.25x. Okay, so this was just a humor part. Okay, so e to power x. So what happens is when you join a PhD and you are in the 4th year or almost in 5th year. So I've taken an extension of year. So I'm in the 6th year right now. So we become such pathetically frustrated from within that we become actually PhDs in experimental condensed matter. Nahi. We become PhDs in cracking poor jokes. So help yourself with my poor jokes. So I cannot help it, but okay. So this is one, and okay. So I always feel ki, why to keep the environment so grim? Okay, the subject is already grim. So let us smile and understand each and everything. Obviously, I'm not going to cut down on rigor any day. Wherever I'm going to cut down on rigor, I will record a lecture which would suggest how to derive that particular thing so that you remain aware on both ends. Because see, even if you clear the exam, to clear an interview, you need the holistic knowledge. So that is why I'm saying, okay, now let us make the graph of it without wasting a time. So at x equal to 0, this would be 1. Now let us differentiate it. So the derivative of cos hyperbolic x would be what? E to power minus x. Sorry, e to power minus x, e to power minus x divided by 2. This is the first derivative. This is the first derivative. So this is e to power x. Now you see the derivative would be positive if e to power x is greater than e to power minus x, or you can say e to power 2x is greater than 1, or x is greater than 0. So for all x greater than 0, your f dash x is positive. For all x less than 0, so I'll do this. So less than 0 means what? E to power 2x less than 1 or x less than 0. So for all x less than 0, your function would be, function's derivative would be negative. So you will have a decreasing function here. How do you think your function's second derivative would behave? It would be completely positive because it will again reiterate itself to a cos hyperbolic. So it will again become a cos hyperbolic. So obviously the second derivative is always positive. So now again come back to what I taught you. For all x greater than 0, function is increasing at an increasing rate going towards infinity. For all x less than 0, function is decreasing at an increasing rate. Every time I make this mistake. Okay, so please keep this in mind. This is symmetric. Okay, so this is how it is going to make. So this is how your cos hyperbolic is going to be formed. I hope it is clear. Okay, now a little bit of okay. So a little bit of graphs like root over x. So how do you make a graph of root over x? This is how you make a graph of root over x. So this is how you make the graph of root over x. This is not defined for all x less than 0. So I'm making the graph for all x greater than 0. How would you think that graph of y equal to x would behave? It would behave in this manner. How do you think your graph of x square would behave? This would behave in this manner. And if I want to make on both ends, so I can make that also. But so you can see one thing. Let us say I want to make the graph of x to power 2n. if I want to make the graph of x ki power 2n, and n belongs to natural number, that is, I'm talking about even powers. So what will happen? Let's say this is your x square. So at 2, x will be 4. But if I make the graph of x ki power 4, at 2 it will become 16. So it has to become a little more steeper. So you increase n, your graph will become, the slope will become steep as. Are you getting the point? See, let's say this is your n equal to 2, n equal to 1, this is n equal to 2, and this is n equal to 3. So you can expect this kind of steepness in the slope. I hope you are getting my point. Okay. Reason, again, you can take the derivative. For everything, you have to take the derivative. Just take the derivative. And also understand, let's say, if you are not able to follow it, just try to write 2 here. So what will be the value of 2 here? So in this particular graph, it will be 4. At 2, the graph will shift to 16. Because x ki power 4, at x equal to 2, it will be 16. So instead of 4, you have to make a 16 here. So just see here, it will shift. So obviously, this graph has to shift in this side. Or otherwise, you can take the derivative. So if you take the derivative, you'll find that the slopes values are increasing. The slopes will be increasing. That's clear. See, x square, the derivative is 2x. For x ki power 4, the derivative will be 4x cube. The slope is increasing. So it is going to get all the more steep. What is slope? Slope is the tangent drawn. What is the slope of function at a point? At derivative, sorry, I'm so confused. The derivative at any point is equal to slope of tangent drawn at that point. So if I'm saying that slope is getting steeper or slope is increasing, let's say this is your slope. Now slope is increasing means what? It will become this way. So obviously the graph would be a little bit steeper. So it will move this side. Okay. I hope I've made sense. Okay. Okay. So I think this is it. There would be a few more things that I'm going to teach you tomorrow with regards to this. But tomorrow we are also going to start with a little bit of quantum mechanics. Let us see how much. With regards to quantum mechanics, I'm saying the point is that I have already recorded a few postulate kind of videos. Please go through it. I have elaborated each of the postulate with a good amount of understanding of, let's say, Kettenbrand notation. I've explained in a few lectures of linear vector spaces. A few of them I'm going to upload today. So till the postulates are getting uploaded, I'm going to continue with these basic stuff. Because if you're aware of these basic stuff, then you can do good amount of physics later on. So I hope to see you in the next lecture. If you are all thinking good about it, or should I not take the next lecture, or should I take it tomorrow? What do you think? Just let me know. So next lecture, I was planning on series. So that is also a basic topic, and usually questions are asked from there. So that is a mathematical physics lecture. So I told you now, there would be 2 lectures that I would take for quantum mechanics. So here, these are the 2 lectures. The basics one, again, it was nothing but mathematics only. But a few of the mathematical foundations we need to make before we start quantum mechanics. So I cannot help it. So just join in the next lecture, which is on series. So this is a different topic altogether. Okay. So I hope to see you in the next session. Till then, take care.